So, let's talk about stem cell therapy. One of the biggest questions out there is, should you use your own cells or cells from a donor? For years, there's been this one popular story making the rounds at medical conferences that has really shaped the answer. But is that story actually true? Well, that's what we're digging in today.
You've probably heard this story. It goes something like this. Stem cells don't really stick around and become part of you. Instead, they act like medicinal signaling cells. They basically show up, shout some chemical instructions to get your own body's repair crew working, and then, poof, they're gone.
And, on the surface, that sounds pretty plausible, right? For a long time, it was pretty much the accepted wisdom. But the question is it really the complete picture? Or is there something big, something crucial that this story is leaving out?
Okay, so let's really look at this common narrative. This idea that cells just send a quick signal and then vanish became the go-to explanation. But to figure out if it's right, you have to ask a simple question. Where did the evidence for this story even come from in the first place? To get to the real answer, we've got to peel back the layers of this thing and look at the original data. And when you do that, a pretty fundamental flaw starts to become really clear. It turns out that entire signaling cell story was built on research that had a massive hidden problem, a flaw that pretty much changes everything we thought we knew.
Okay, here it is. Here's where it all went a little sideways. The vast majority of the studies that supported this whole theory, they weren't done on people. They were done on small animals, like rats and rabbits. And that single detail, right there, is the key to this entire misunderstanding. So here's the core of the problem. A single rat is just too small. You can't get enough bone marrow from one little guy to do a stem cell treatment. So what did the researchers do? Well, to get a big enough dose, they had to pool the bone marrow from lots of different rats. And you see the problem, right? The cells being injected weren't the animal's own. They were foreign donor cells.
And that brings us to a super important definition. When cells come from another individual, from a donor, they're called allogeneic. So kind of, without realizing it, the very research that built the medicinal signaling cell theory was almost exclusively looking at what happens when you inject foreign, allogeneic cells.
This really sets us up for a tale of two totally different cells. Because what happens when you don't use foreign cells? What happens if you use cells from the patient's own body? As you're about to see, the outcome completely flips on its head. See, when we look at modern tracer studies, this is cool stuff where they can actually tag a patient's own cells and follow them around. That old theory just completely falls apart. The data paints a very different picture for what we call autologous cells.
So let's break it down side by side. You've got the allogeneic donor cells. Your immune system sees them as foreign invaders and attacks them pretty quickly. So yeah, they only have time for that brief signaling. But autologous cells, your own cells, they're accepted. They're recognized. They get to stick around, integrate themselves, and can actually become brand new tissue. So why the huge difference? I mean, it's pretty dramatic, right? Well, the answer is actually beautifully simple. It all comes down to one of the most powerful forces in your body, your immune system. Think of it like this. When an allogenic or foreign cell enters your body, your immune system's alarms start blaring. It immediately identifies it as an intruder. This kicks the killer T system into gear, and that system is designed to do one thing and one thing only: find and eliminate foreign cells to protect you. And trust me, it is very good at its job. But here is the magic of using your own autologous cells. Your body recognizes them. They've got the right ID badge, the secret handshake. The killer T system sees them, gives them a nod, and says, hey, you're one of us, and just leaves them alone to get to work. They don't get taken out.
So let's bring it all home. Why does this distinction actually matter to you? Well, it's absolutely key to understanding the real potential of regenerative medicine. I just love this simple way of putting it from the source material. Unlike those allogeneic cells that get kicked out of the club almost immediately, autologous cells get to stay and play. They're welcomed by the body so they can get down to business for the long term.
And what does stay and play actually mean? It means these cells have time. Time to stick around, to differentiate, which is just a fancy way of saying transform, and to literally become new, functional parts of the tissue they were injected into, whether that's cartilage or muscle or something else entirely. So, the bottom line is this. That old medicinal signaling cell story really only applies to foreign allogeneic cells. The real story, the one that applies to your own autologous cells, is one of long-term integration and genuine repair. They're the true stay-and-play cells.
And that really just leaves us with a final question for you to think about. On the one hand, you have cells that offer a temporary signal before your body destroys them. On the other, you have cells that are welcomed, that stay and that actively become new tissue. knowing the difference. Which team would you want working for you?